Hello, it's Stuart Wright again here, and I'm back with another one of my videos to help you understand how to combat the scourge of modern day living, which is condensation and mould. Today I'm going to do a demonstration about how to get rid of condensation and mould in bathrooms in your house that don't have an exterior wall. So it might be your internal ensuite bathroom or from a master bedroom or something like that. I think you know what I mean. So we're talking about extractor fans that have to push air along long lengths of ducting to get the moisture out to atmosphere. Now, the biggest problem with this is that generally what people will do is just go and buy a standard 4-inch extractor fan. Something like this, for example. Now, this is what we call an axial fan, has a little propeller in the side, so it's a little bit like a propeller engine. And this is the kind of thing that you normally fit to an external wall in a bathroom to try and get the moisture out. So I'm just going to demonstrate today how this performs on a long length of ducting. Now, I've got two different types of duct here. I've got a round rigid duct and I've got flexi duct. And both of these ducts will set up back pressure, which will reduce the performance of the fan when I put it on the duct. So what you're looking for on the rig test is that white puck at the bottom will move up the tube. Now, as you can see, I've got the duct on the fan now and it's not moving at all. There you go, that's fan number one, an axial fan. Axial fans are only really appropriate for bathrooms with external walls. So what to do if you have a bathroom with no external walls and it may be a couple of meters away to the external wall. So what you need is a duct possibly running through your loft space. Now, as you can see here, I've got a round rigid duct. Now, EnviroVent, we prefer, if we possibly can, to install all of our ventilation equipment with round rigid ducting. And that's because air travels in a nice helix, a corkscrew shape down the tube, and doesn't have as much resistance against it. Whereas if you find this kind of ducting, flexi ducting, all the ridges that you see here mean that the air bounces around a bit more, so it creates a little bit more pressure, back pressure, a bit more resistance to the travelling air. So it just makes it a little bit more difficult for that air to go out. Now, the fan that I'm going to introduce you to today is one of our latest innovations. This is the EcoDMEV, and as you can see, it's a handsome looking fan. It's a very quiet fan. It's also a centrifugal fan. Now, I'm just going to say one thing here that's a bit technical for any of you people out there that are interested in the property world. This is a trickle and boost fan, which means it gives you lots of points in sap. Now, to anyone else who hasn't heard of those things, sap is something that oozes out of a tree, but those of you that are in the property world, you know exactly what sap ratings are, and this gives you lots of points in sap. So anyway, I'm back to the demonstration. So imagine you've got an internal bathroom with no external walls, and you've got a great big long length of duct. The great thing about this fan is it's intelligent, so it actually works out how much pressure it's working against from this tubing, and it will actually send a little message to the board to speed the fan up so that you're getting exactly the duty that you need to get moisture out of your bathroom. Okay, so I'm going to stick this on, and what you'll notice is there'll be a small delay before the puck starts to move up the tube. On we go. So there you have it. What's happened now is, and I'm a long way away, I can increase the pressure in here by making kinks, and what will happen is that this fan will respond. It will respond to the back pressure and speeds up so that it gets the puck all the way up to the top of the tube. So there you have it. A centrifugal fan is definitely the answer to getting moisture out of an internal bathroom, but something that's intelligent so that it works out how much pressure is really the new innovation in trickle and boost fans. That's the EcoDMEV.